Percent change problems are always going to be about a percentage increase or a percentage decrease. And these problems can be tricky, but the key is to always come back to the percent change formula. The formula tells us that the percentage change divided by 100 will be equal to the difference between the original value and the new value divided by the original value. What we want to be able to do is find two of these three values somewhere within our problem. For example, find the difference and the original number within our problem and then solve for the percent change, which would be the only remaining unknown value. Or find the percentage change and the difference in our problem in the question, and then solve for the original value or the original number, which would be the only remaining value. So we need to find two of these three values somewhere inside of the question, plug into the percentage change formula, and then solve for the missing value and make sure we're answering the question. For example, a percent change problem would be something like this. Sarah gained 10 pounds, and she now weighs 7% more than she did before. What was her weight before? We know this is a percent change problem because her weight is changing. She had an original weight, now she's gained some weight, and she has an ending weight. So there's a change going on, and we want to look at that percentage change. So we just go right back to our formula, and we're looking for two of these three values. So what about percentage change? Do we have that? Well, yes, we do. We know that her weight changed by 7%. It increased by 7% because she gained weight. So we could go ahead and put this 7 in for percent change and call this 7 over 100 on the left side is equal to, on the right side, the difference divided by the original number. Okay, well, for the difference, she gained 10 pounds. Now, do we have the difference between her original weight and her new weight? Well, yes, we do, because she gained 10 pounds. So we don't know what her original weight was, and in fact, we don't even know what her ending weight is, but we know that she gained 10 pounds. So the difference between her original weight and her new weight will be 10 pounds. So we can plug in 10 for the difference, which means the only missing value is her original weight, which makes sense because the question asks what was her weight before or what was her original weight. So we'll put in a variable for that, let's call it x, and now we can simply solve by cross-multiplying. So we do 7 times x to get 7x. We do 100 times 10 to get 1,000. And then if we divide both sides by 7, we end up with x is equal to 1,000 over 7, which turns out to be about 142.86, so we can maybe say approximately 143. So what this tells us is that her original weight was 143 pounds. She gained 10 pounds to go up to about 153 pounds, which was a 7% increase in her weight. Sometimes these problems can be even a little more complicated, and we'll have to apply the percentage change formula twice. For example, with this problem, we have the price of a stock rose from $150 to $200, and then it fell by 35%. What was the percentage change overall? So there's two separate events happening here. The first is that the price rose from $150 to $200. So if we apply the percentage change formula, what do? Well, we don't know the percentage change there, so we can go ahead and put x in for that. We know that the difference was 50 because the price changed from $150 to $200, and 200 minus 150 is 50. So there was a $50 change, so we can put that in. And then the original value was $150. Then we cross multiply and we get 150 times x is equal to 100 times 50, or 5,000. Then we divide both sides by 150 and we get 5,000 divided by 150, and we get x is equal to about 33.3, which means that our percent change, because that's what we were solving for, was about 33%. But then we have a second step. From that point, the price fell by 35%. So we go back to our percent change formula and we plug in. We know the percent change was 35%, so we plug that in to the formula. The price got up to $200 after this first step, so the price is sitting at $200. Now it starts to fall by 35%. So the original value is $200, but we don't know the finishing value or the finishing price. So we can put the unknown value x in for the difference, but then we know the original value was 200. And then we just cross multiply to solve. So 200 times 35 is 7,000, and 100 times x is 100x. Then we divide both sides by 100, and we get x is equal to 70. Therefore, we know that the finishing price was 200 minus 70, or $130. So we know the finishing price was $130. And to find the percent change overall, which is what we were asked for, we know that the percent change on the first step was an increase of 33.33%. We know that on the second step, the price fell by 35%. So if the price rose by 33.33% and then fell by 35%, that means overall there was a price decrease of 35% minus 33.33%, or 1.67%, approximately 1 2/3%, was the net decrease or the percentage change overall.